everyone! Today, we're diving into the fascinating world of physics as we explore Newton's 3 laws of motion. We'll talk about what motion is, who introduced these laws, their objectives, and the real-life examples you can easily relate to. So, let's get started. But first, let us define what is motion. Motion is simply defined the change position of an object with respect to a time. If something moves from one place to another, that is motion. So who introduces the 3 laws of motion? These laws were formulated by Sir Isaac Newton, one of the greatest scientists of all time. His 3 laws explains how objects move and interact with forces in our world. That's why they're called Newton's laws of motion. So, before we break down each law, let's understand their main objectives. These laws help us to describe how object moves when force acts upon them. 2. Predict the motion of objects in different conditions. 3. Explain the relationship between force, mass, and acceleration. Now, we're going to talk about the Newton's first law. So it states that an object at rest, it stays at rest. If an object is in motion, it stays in motion, unless acted upon by external force. This is called inertia, the tendency of objects to resist changes in motion. For example, if I don't push this book, it stays still. But when I apply force such as pushing, it moves. That's how. Another example is this one. So I called Jenny Ann to run, and then suddenly I said stop. When you observe, the body of Jenny Ann leans forward because it wants to keep moving due to its external force. We refer it to the Newton's first law that if an object is in motion, it remains in motion. And then when I call Jenny Ann to stop, or when I command Jenny Ann to stop, that is when the force acted upon. So that's why her body leans forward because of the external force occurred during the process. Now, we're going to move to the law of acceleration. So, what is acceleration? Okay, the second law explains that force equals mass times acceleration. That this means that heavier objects require more force to move than lighter objects. Here are some of examples. So, as you can see, there are 2 chairs. First chair is unoccupied, meaning it is lightweight, and the second chair is having a person sitting on it, so it's more having a high mass. In these 2 chairs, we're going to apply the same force, the pushing force. As you can see, the first one who have no person sitting on it moves faster than the second chair. It is because it has a lesser mass. However, the second chair with the person sitting on it, it is more likely a heavy one to carry or to push because it has a greater mass. But pin it to your mind that both of the chairs, the force they use is the same. This means that the heavier objects requires more force than a lighter object. So, if gets na ninyo, let's move to the third law of motion, such as the interaction. So Newton's third law says that every action has an equal and opposite reaction. This means when objects applies force on another, the second object pushes back with the same force. So they have equal and harmonies. See for instance, Kim jumped on the floor and Kim uses forces. So what force did Kim use? so it is the downward forces. And to make him repeat the jump, the ground or the floor also uses forces, such as the upward forces. In that way, they interact each other to make a harmonious effect. They have an equal interaction with each other. As you can see, they have an opposite reaction uses, an upward, and downward, that makes them more uniform and